Hi, and welcome to day 3 of Rapid Plus TCT 2022. I'm Brandon Ribic, the Technology Director at America Makes, and I'm really happy to be joined here today with my colleague from Lithoz, Beth Bornick. How are you doing, Beth? Good to see you.
Good. Thanks for having me.
Yeah, you're welcome.
Yeah.
You're welcome. Are you enjoying your time this week at the show?
Oh, it's been great. We've had barely a quiet moment, so.
Wow,
Good.
that's cool. That's cool. So, are you? Have you been spending a lot of time on the exhibit floor, or have you been,
A little bit. I've been mostly at the booth. We were here
Okay.
last year, and it was certainly much quieter at Rapid, but this year has been really back to really excellent energy on the floor. So.
That's great. Yeah, I tell you, I kind of share the enthusiasm for everybody kind of getting out and getting together.
Yeah.
And I know I've seen you at a couple things here in the last few months. I think you were at the TRX that we had back
I was
in
in
Utah.
Salt Lake,
So
yeah.
that was fun, right? It was a
That
good
was
chance to kind of get out.
Yeah.
Did you get to kind of like go around it all whenever you were there and check out the sites a little bit?
I did. I went down to, there was another conference on composite materials, and I drove down to that below Salt Lake and then drove back through the mountains. So
Cool.
It was nice.
Cool. So, I'm very intrigued by the technology that you have at Lithoz. Ceramics and additive manufacturing of ceramics, it's something that, at least in the last year or so, I've been really fortunate to get to learn a little bit about it. We have some good colleagues, so Acer's put on a great panel discussion that I was fortunate enough to be a part of with folks from, I think it was Raytheon and Lockheed and Igor Levin at NIST, who, in my opinion, is a leader in this space. He's been working in this space for several years now, trying to workshop and develop strategies and understands what's needed. And I think, the technology you're working on, some of the things I've learned off of your website, I thought, boy, what a great chance. We're all going to be at Rapid. Let's get together.
Yeah.
And so why don't we start just talking a little bit about what is the technology that Lithoz has and how's that involve ceramics?
Sure. So Lithoz is more than 10 years in the ceramic additive manufacturing realm. So we've got a very mature technology, and we're a DLP printer process. So what we're doing is using ceramic-loaded photocurable resin, and we're illuminating it with a blue light in order to build up our part layer by layer. So this is a process that lets us do very high resolution parts. So we tend to be really great at small and complex ceramic parts. We're also, because we came out of ceramics engineering origins, we're very dedicated to having a great variety of materials and material properties that are comparable to conventionally manufactured ceramics. So that is kind of our strong spot there. But it's not surprising that ceramics are really just kind of becoming visible, because really we're a technology, a material that comes into play after plastics and metals fail. Extreme environments, and harsh heat or chemical conditions. So when people come to ceramics only after they've really been through those other materials.
Yeah, so kind of curious about, so you mentioned it's a DLP, photocurable resin, and so the technology, or I guess potentially the solution that your organization offers, are you offering the ceramic powder? Are you helping people to select ceramic powders? Or, in terms of those feedstocks and the resin, does that come from you, or do you suggest the things to use in your equipment, or how does that work?
Well, so we're printer manufacturers.
Okay.
So our materials are developed specifically to work in our printers and with our wavelengths. We use visible wavelength. We're printing with blue light, not ultraviolet or laser.
Okay.
So our resin systems are really the key to making these ceramics printable on our printers. So we have a standard catalog of materials that are pre-mixed cartridges of the ceramic loaded resins. But we're also an open platform. So if a customer has a ceramic powder that they've already qualified for their application and they want to make that printable, that's part of what we do at Lithoz America and also back at our Vienna headquarters. But Lithoz is kind of an independent operation where we can do materials development and make your powder printable on our system.
Oh,
And we're also open to the extent where if the customer has capabilities of developing their own resins and powders, they can make their own slurries completely
okay.
on their own.
So you mentioned the blue wavelength light. Are there some special things about that? Does that impact the processing time or the feature resolution? Are there some unique things about that wavelength?
That's chosen because you have to get the light to penetrate into the slurry with the ceramic, and the ceramic material is reflective in a way that just a polymer is not. So that wavelength actually penetrates better into the material, into the resin than an ultraviolet.
Okay. All right. So there's a reason why that wavelength was chosen.
There's a reason for that.
Okay. Cool. I think that's great for folks to know. Now, I guess another thing that folks talk about is the size of the machine. About what's the build volume of that piece of equipment?
Well, the machine we're showing on the floor today at Rapid is our entry-level Serifab lab, and the build plate is about a business card size, if you think of that.
Okay.
Our standard workhorse printer, our S65, is more of an iPhone-sized plate.
Okay.
And for us, we're focused on ceramics that are small and parts. You want relatively thin walls, so we do a lot of work with lightweighting the parts, helping people develop those applications. You're not going to be printing big, bulky parts with a DLP printer.
Okay.
Our build platform comes down from the top, so the more weight you get on that, the more challenging the print becomes. So those are great applications for other technologies.
Okay. No, I'm glad to know that, because myself, I've used refractories in thermochemical processing of steels, and those are a little different than some of the ceramics I think you're talking about. And so that being said, what is kind of like just a ballpark answer is fine for the wall thickness. You said you can get fine features. About how fine can you get?
Well, with our standard printer, we're doing, it's a DLP process, and it's digital pixels of about 40 micron.
Okay.
Our layer thickness can go down to 10 micron for parts that need that fine of a resolution.
Wow.
And you would be printing a green ceramic, so when you're sintering, those are going to go even smaller, because there is shrinkage as the binder burns out and the part comes to full density. So there's definitely variation involved there as to what you set for your layer size and so forth. But,
so a 4 thou wall thickness is not outside of the realm?
For us can be up to a couple of millimeters. So what you're going to be looking at is the thicker the wall, the longer the binder burnout time, because that binder has to work its way through the pores of the part and out to the surface. So we always try, when we're helping people to design for ceramic additive, to make sure that the wall thicknesses are fairly uniform and there aren't abrupt changes from a really bulky area to a really thin area, because those are areas where the part can crack as the binder burns out quickly from the thin wall and more slowly, and it continues shrinking out of the thick areas. So we do a lot of helping people with feasibility studies and take a look at their parts and show them ways to maybe make it more printable and sinter more successfully.
Yeah. So, and I think that's a great point that you bring up. You need to think about not only the product design, so the geometry, but also the post-processing.
Yeah.
So, in that regard, one other thing I wanted to ask about the technology solution you have is the types of ceramics. So we say ceramics, but there's a lot of different ceramics. So what are the ceramics that you commonly work with right now?
Sure. Our most popular ceramic, it's used for the most applications, is alumina. So aluminum oxide. We're working mainly with oxide ceramics, which can be fired in an air atmosphere, don't require high pressure for sintering. So those are generally what our customers turn to first. So alumina and zirconia, very hard, like the ceramic steel, like we call it.
Sure.
We have a lot of materials that are in our standard catalog, so materials that have been characterized and developed over many years to have the same part characteristics as a conventionally manufactured ceramic. But then we also have development materials. So these might be materials that a customer has requested, alumina toughened zirconia, for instance, something highly abrasive resistant, or something tailored for maybe dielectric materials, things that we're working on developing. And those are also available as more of understanding that it's in development. We're still working on the parameters. It might take more iterations to get the exact dimensions after the sintering. So the materials we have a subset of materials that are focused on electronics. So we're doing actually some development in multi-materials. So you might be able to combine, instead of having one vat of material with a ceramic, you'll have a second vat that might be stainless steel, and you might be able to develop a part that's both ceramic, say zirconia, and stainless steel.
Wow.
So things like that are things we're developing for the electronics area. But then we're also working with a lot of medical and dental customers on parts that might be biocompatible. So all the way from dental crowns in zirconia, which is a very, very good material, to very biocompatible. There's no toxicity in the body, to even bone replacement materials that will gradually, over time, allow new bone to grow in and heal a broken area.
Wow, that's exciting. That's really neat. Several things you mentioned there that are really interesting.
Territory there.
Huh?
A lot of territory there.
Oh my gosh, yeah. Thinking about what you mentioned, sorry, about some of the materials, I'm curious, you mentioned some materials in development. Are you looking at carbides by chance, or like silicon carbide, tungsten carbide, or?
We've definitely done some silicon carbide printing. The key for us is finding a customer that's got a pressing application, and we will take, we get it to the point where we know it's printable, but we want to work with the customer to make sure it's suitable for their application. So, the dark materials like that are the most challenging for us with a light-based process. So things like silicon nitride is also a dark material that we're actually doing some good applications with that now with customers. So that's what we would be looking for, is someone who's got a silicon carbide application, and let's take that to the next stage and make your parts with it. So
that's great. Yeah. So I think you mentioned some good things about medical and electronics, but I have to admit, when I was looking at your website and learning a bit about your technology recently, I saw some things that looked like they were for casting applications. It almost looked like they were turbine blade cores. And, I think you mentioned thin walls, and we saw some good data here from Brian Bauman of Honeywell this week about using AM for casting. Is that something that you're looking at? Is those types of ways to complement casting?
Yeah, we have a casting core material. It's a silica-based material that can be leached out and is used for the internal channels on a turbine blade. So we have, in fact, the customer that we worked with as we were developing that material, we actually, for them, evolved a model of our system with a larger build platform. The casting material is much lighter than the other ceramics that we work with, so that does allow us to do a larger build in a lithography-based process. So, the casting course is definitely an application. We'd like to try some molds with it too, but we haven't had a customer come to us with a part. So.
Well, we've been talking a lot at America Makes with the community about casting and forging replacements. So hopefully there'll be an opportunity in the future. I hope so.
I think we plan to be at MMX, and maybe we'll have a chance to talk to some people there.
Yeah, for sure.
Yeah.
So in terms of other things, in terms of this technology space and next steps or the future, what do you kind of see for ceramics additive manufacturing? What do you think we need to be working on?
I think we need to get the awareness out there to the broader community. You know, we go to ceramic shows and we educate them about additive, and we go to additive shows and we educate them about ceramics.
Yeah.
But what we need to do is we need to push out into the aerospace and the automotive markets and say, hey, you know, ceramics are a material to consider when your polymers and your metals fail. So the extreme environments,
Sure.
high heat, vacuum, caustic environments, abrasion resistance. So what we really need to do, I think, is to get more applications in and get more publications, get more studies,
Yes.
show the actual results of these materials in these extreme environments, and get that information out. So, you know, we love to do new material development. We love to work on, you know, specific applications. But, you know, I don't know that there's any one focus area where we need research. It's really about getting with customers and working together on the further development of that.
That makes
that
total
material.
sense. I mean, we
Yeah.
do that a lot at America Makes, and we've done that a lot in our 10-year history. So I think
Yeah.
that's a great idea.
Yeah, I mean, the tool is there, you know, the technology is really solid. It's just getting new applications and branching out into new materials.
Sure, sure.
Okay.
Well, Beth, it's good to see you. Thank you so much for
Thank you
joining me
for
here
having me.
today.
Yeah,
It's
thanks.
been a great pleasure. I hope you enjoy the rest of your time at Rapid.
Will do.